what Gwen has introduced, my name is Richard Ng. I'm a co-founder of Syngtec, and the topic for today's speech would be Rule for a Safer Future using ETFE film. So just a quick intro. As I alluded to earlier, the company was first started in the Philippines at the behest of AGC to market ETFE, essentially. At the time, ETFE was not a very well-used product back in 2013. So we were tasked to market the product in Philippines to try to see if the reach of AGC can extend beyond the traditional markets of Singapore and Hong Kong as far as ETFE is concerned. So in this slide, the BCD essentially refers to the value chain of the entire ETFE. So there is a collaboration between AGC. They are the biggest manufacturer of ETFE in the world. So there is a collaboration with Syngtec, and I'm also an ad hoc consultant for AGC, hence my participation in today's event. C, the raw material that AGC sells will be purchased by fabricators who will process the ETFE into the panels, very much like glass fabricators that will cut, that will prepare, that will process into the form that has been designed. And then finally, once the product has been produced and delivered, we will work with our local partners in the various countries to make sure that they are properly installed in conjunction with the fabricators that we work with. So we are present in Philippines, of course. HEAD is our local partner, and we have partners in Indonesia, Thailand, and Vietnam as well. So what is ETFE? The fortunate thing is that since 2013, there has been increasingly extensive use of ETFE around the world, particularly in stadiums. You might have seen the use of those products in stadiums, particularly in the US. All the new stadiums in the world these days actually use ETFE in some form. I will share that in the subsequent slides. But by and large, I'll just run through very briefly the characteristics of ETFE, how they are being applied in buildings, the type of ETFE installation, and the comparison with other materials such as glass, PVC, PTFE, and what have you. So this is just something that I lifted from Wikipedia in case anyone is interested in the scientific description of ETFE. It's just ethylene tetrafluoroethylene. And like what the earlier video has demonstrated, it is a fluorine-based plastic, and it's just very well developed and researched by AGC. I will share a video. This is lifted from the YouTube. It is a fantastic source material for ETFE. So this is one of the many videos that I found that perfectly describes and depicts what ETFE can do and the advantages of which. So the video that you saw just moments ago is a stadium in New Zealand, Dunedin. The entire facade, plus the roof of the stadium is all ETFE. You probably can't make out or touch it, but it is something. There are multiple videos showing that stadium, which is a unique material or product in itself used for facade and roofing. Now, why is that the case? On the left side of my slide, you'll notice there's a list of characteristics for the ETFE. It has exceptional transparency, high light transmission, and probably the most critical characteristic of ETFE is very, very lightweight. It is akin to plastic, but it is not plastic. It is, like I said, a fluorine-based product. So because it is lightweight, it allows for very long span in the panels, unlike glass, where it's probably at the very best 1 meter by 1 meter or 1.5 for roofs. It can take on any shape. So think of it as fabric that can be tailor-made into whatever shape the architect wants or the designer wants. And also because it's lightweight, very minimal support structure. So you're talking about extremely high savings in steel tonnages. Fire safety, what is non-combustible? Again, YouTube is a fantastic source of material for fire safety. It doesn't propagate fire. So once the fire is removed from the ETFE, it stops burning, and there are no drips. Chemically, it is inert to, in fact, almost all active solutions. Self-cleaning. Again, unlike glass, it's like you need to have maintenance, but as long as you have rain, ETFE cleans itself, and the product is recyclable. That's 7. You can also introduce solar shading on ETFE. So if you have specific U or G value that you want to achieve, and that can be customized with the use of prints. So this is sorry about that. And this is a unique and very important research that AGC has undertaken, and he has moved on since 2013 to ensure that the reflectance of solar or UV improves with every new development that they have done. So the one on the left is current film available in the market today. The one on the right is K ink. The one on the left is standard silver. So AGC has developed the K ink that improves the reflectance of solar. So if you look at the numbers in yellow, it will tell you the story of how much of a reflectance it has improved. And they are also now moved into an even better ink, which is the W ink. And this one has the best reflectance of solar for ETFE. And also to add, AGC is the only manufacturer of ETFE and prints that will guarantee its product for a minimum of 10 years. No other manufacturers can do that. So that's how far and how well they have done their R&D. Number 9, another characteristic is the superior weatherability. The product was first used, I think, about 35 years ago. I apologize for the number here, 27 years. It should be amended to 35 years already. So the optical properties and the mechanical properties, by and large, stays about the same. So it's a highly durable product. And also the R&D involved undertaken by AGC is to improve on this haze and high clarity. So that is something that's under R&D right now. So in probably end of the year, as I was told, that this product will contain low haze and high clarity to a very large extent when they push out the product. And finally, one of the key characteristics is the strength of the ETFE. It can take on the weight of a car in this form. So the critical considerations in ETFE application, importantly, other than making sure that the loads are properly taken into account, you also want to think about the seismic loads, the surrounding buildings, and others. Glass has been a dominant product for roofing and facade for, I think, since it was invented. But with it comes various disadvantages. For example, in volcanic regions or where there's high earthquake activities, typically when building collapses, there'll be a lot of debris. So in the use of ETFE, you're talking about minimal, not minimal, but definitely relatively less steel structures compared to using glass. And you don't have glass shatters, unlike ETFE, which is essentially plastic in a lot of ways. And also for surrounding buildings, we're talking about if you're using glass as a roof for commercial complexes, anything that falls from the sky, be it steel pipes, be it heavy objects, you immediately break the glass roof in the commercial complex below. So for plastic, it's just essentially puncture through the ETFE without causing any shatters. And then finally, the fire safety, chemical spills, and maintenance are something that you also want to consider using ETFE instead of traditional glass. So we'll move on to applications of the ETFE. And again, these are all pictures I lifted from the YouTube. So it is very universally accessible by everyone. These two projects, the one on the left is the entertainment sector in Kazakhstan. There is an entire YouTube video describing how the entire facade, which is ETFE, was built from scratch. So it's actually a discovery program on this project. And on the one on the right is the Beijing Aquatic Center, which is also in the discovery program available in the YouTube. So you notice it's like the ETFE can take on any form. It doesn't really have very rigid structure, which is what the architects and designers love these days. More stadiums, the Bird's Nest, also in China, and the National Stadium. The retractable roof is made out of ETFE, and at the same time, you will also notice that ETFE acts as a projection screen as well. So this is a project that I did in the Philippines, or installed in the Philippines. So this is the Mactan Airport, particularly for walkways from the drop-off point to the terminal in Cebu, Mactan. Skylight, use of ETFE in skylights. This is in the Philippines Mall. The one on the right is in Hong Kong for artistic expressions. And the use of LED with ETFE, and it gives you a completely different look at night with the use of lights. And in fact, you can probably incorporate this. AGC can probably work with Philip, in making sure that LES can also be incorporated into this product.
Yes. Thank you.
So I'll move on to the two types of ETFE installation that is available in the market. One is the single layer tension system. This is a project in Jordan. You notice on the roof, those are entirely single layer ETFE. Facade using single layer as well on the left, and also for a school as a canopy on the right. So it's a combination of transparent ETFE and opaque PTFE. And the second type of ETFE installation are your cushion. So it's essentially two pieces of ETFE inflated with air in between. So the entire system will consist of an air pump or air inflation unit. You can see the bottom left, a typical picture of an air inflation unit, pumping air through an air tube into the space between the two layers of ETFE, creating an air pressure within the two layers. And all these are supported by steel and aluminum. Just a close-up of an air inflation unit. The one on the left, you will have a primary blower and a backup blower, and it will have to be installed within 100 meters of the ETFE project itself. So you notice on the picture on the right, the air is pumped through a stainless steel pipe, and then after transported across all the different ETFE panels and relayed into each individual panel via the air tube. So I was also mentioning that they are all supported by steel structures and aluminum extrusion. So these are typical cross-section and side profiles of aluminum extrusion. Well, we can probably talk about this in detail, but we don't have the time for this. So I'll just skim through this presentation, this particular slide. So comparisons with other materials. In a snapshot, I'm talking about comparisons with Lemiglass, insulated double glaze, low E, PVC polycarbonate, PTFE. So you will notice that the key or the fundamental differences between this product and ETFE, other than PTFE, is essentially the weight itself, and also the U value and the G value, which you can customize according to your set values or what you wish. So this is just a snapshot of the very many characteristics of the different materials that are in use today for facade and canopies. So increasingly, you will notice that ETFE has been considered as the go-to product, particularly for roofing, simply because of the nature of its of the product in itself, and how flexible it can be in offering architects and designers the flexibility and also the non-restriction as far as imaginations can go. So I think that is fundamentally or rather essentially the end of my presentation. I hope I kept within the time.
Yes, you did, Richard. Thank you for the sharing. I love especially all the project references. They all look so fantastic and aesthetically very nice. So Richard, we do have a question from our participants. This participants ask, ETFE, can your company also assist in the design development?
Yeah, in fact, we encourage our customers to get us involved from the very beginning, simply because the calculation of loads, the engineering, and what have you, it's not something that is familiar to everyone. Everyone is familiar with glass. The loads involved in accordance to the building codes for each country. But ETFE is a completely different animal. And you will need to understand that we need to optimize the steel to make sure that the steel structures or the use of steel tonnages are minimized. Otherwise, it's like a complete waste of resources if you just want to use ETFE but maintain the same kind of steel structure that is supposed to be set aside for glass in the very first place. So I always encourage customers to work with us from the very beginning so that we can work together, either with our steel designer or with their own steel designer in coming out with an optimized structure.